Okay, we're in business now. Okay, so as I was saying, so in the videos, I think the first video that is posted under this chapter, we talked about the difference between what we call common names and systematic names. And basically, what you'll find is that the common names, which are usually the older names of different chemicals, is based on the properties, chemical and physical, that the compound may display, and not on the composition. So based on the common names, you won't be able to tell anything most often what the composition is. Now, in the case of systematic names, which chemists prefer, you can tell based on the name.
Okay, girl.
I'm sorry, if you're not asking a question, folks, please mute yourself. Okay, so as I was saying, chemists prefer more often than not the systematic name, because based on the rules that we're about to learn, you can determine the composition and the formula for the particular substance. And as I said before, the rules that we're going to discuss have been formulated by IUPAC, the International Union of Pure and Applied Chemists, all right? So just to give you some examples of the difference between the common names and the systematic names, I'm just going to choose one, just to show you the difference. If you look at this compound, NaHCO3, right? The common name is baking soda, right? That doesn't tell you anything much about the composition of the particular compound here. But if you look at the systematic name, you see sodium hydrogen carbonate, right? Even if you didn't learn the rules, right? At least this gives you some idea as to what is present in this compound. You know it has at least sodium, hydrogen, and carbon, and the 8th part indicates that oxygen is present, all right? So that's just one example, all right? And the video goes into a discussion of elements and ions, which I'm going to assume that, unless you have any questions about this, I'm going to assume that you have an understanding as to how ions are formed. What I really want to get into is how do you determine the formula of different compounds based on the names, and vice versa. And it depends, the rules depends on the class of compounds. So let me just get out of this here and talk about a group of compounds known as binary ionic compounds. All right. Now, the term binary means two. In other words, there are only two elements present in the compound. Ionic means, as the term suggests, it's an ionic compound, which are formed from ions. And you would have learned about ions being positive and negatively charged, right? So an example of a binary ionic compound would be the compound formed between sodium ions and chloride ions, or between, let's say, calcium ions and the iodide ions, and so on and so forth, right? These are examples of binary ionic compounds. Now, as I said before, they are made up of only two elements. Because it's ionic, one of them must be metallic, and the other one must be non-metallic, all right? So basically, that's what we're talking about when we're talking about binary ionic compounds, all right? And there are some rules for naming these compounds. So the first rule, I'm just going to go through briefly because it was already covered in the video lectures, is that if you're naming these compounds, the name of the metal comes first. All right? And then the next rule is that the stem of the name of a nonmetal comes next. And then the third part is that the stem or the nonmetal, after you have the stem of the name of the nonmetal, you add this suffix IDE, right? So basically all these compounds end with the name or with the ending IDE, right? So for example, this compound here is known as sodium chloride. All right, because the metal is sodium, and then the stem of the name of the other element is chlorine. So we use chlor, that's the stem, and then it ends with IDE. Or in this particular case, calcium iodide. All right, the name of the metal is calcium, then the stem of the name of the nonmetal, which is IOD, iode, and then IDE would be the ending of that second part of the name of that compound, all right? Another thing I want to talk about is the fact that you can determine what the formula is based on the name. So let's say you did not know what these formulas were, right? And let's say that you're asked, what's the formula for sodium chloride? Then what you would do is go to the table, not this table, but in the tables that I've posted in Canvas, I've listed on 3 pages, 3 lists of common ions, common monatomic ions, all right? And also polyatomic ions, which we will get into later on. But for now, we're dealing with monatomic ions. So what you do, for example, in the case of sodium chloride, if you're given the name sodium chloride, then you look up the table and look up the formula for sodium, the sodium ion, that is. And if you look it up, you see that the formula is Na+, which means that it has a +1 charge on that ion. And then you look up the formula for the chloride ion, and when you look it up, you see that that has a -1 charge, right? Now, whenever you're putting or writing down the formulas for these compounds, you want to make sure that the charge is canceling out. In other words, the total number of plus charges must be equal to the total number of negative charges. In this case, it's already in that situation, right? You have 1 plus charge on the sodium ion and 1 minus charge on the chloride ion. So therefore, when you put these together, the final answer would be NaCl. All right, and that's it, okay? In the case of calcium iodide, you go to the tables again and you look up the formula for the calcium ion. You see that the calcium ion has a +2 charge, and then you look up the formula for the iodide ion and you see that that has a -1 charge, right? Now, in this case, you have a +2 charge, you have a -1 charge, but remember I said that the charges must cancel out. In other words, the total number of plus charges must be equal to the total number of negative charges. So how do we achieve that? We simply multiply this by 2, right? And therefore, when you put this together, and please note how this is done, the final answer becomes CaI2, right? In other words, this 2 here becomes the subscript for the iodine in the formula. Another thing I want to point out is that in both cases that we're done here, you'll notice that I have not indicated the charges. You should not have any charges in the final answer, right? The charges basically helps you to determine how do you get the charges canceling out by multiplying one or both by a particular integer, all right? So that's basically how that is done, all right? So with that said, let me start you off on assignment number 5. And for those of you out there in Zoom, I'm going to publish it shortly, so give me a minute. All right. Okay, so let's see here. Close this here. Okay, so I've just published assignment number 5. Now, for you guys out there in Zoom, please note that there are 2 links for that assignment. You have chapter 5 here and then chapter 5 addendum here, right? So make sure that you click on both of them, because basically I'm combining both of those to make that one assignment. So let me open this up here and get you started on the first question. Okay, so the question says, give the formula and the name of the compounds formed between each pair of the elements listed below. So we're talking about binary ionic compounds in all of these examples or these questions right here, right? So the first part, the first column, you're supposed to give the formula, and then in the second column, you're going to give the name. So the first one here is beryllium and fluorine. So as I said before, what you would do is go to the tables and you look up the formula for beryllium ions and fluoride ions. And if you do that, you'll see that beryllium has a formula of Be, the beryllium ion that is Be2 plus, and the fluoride ion is F minus, right? So based on what we have discussed earlier, how would you get the charges canceling out? Yes, sir. Multiply the fluoride by 2, right? So what would be the final answer as far as the formula is concerned when you combine these two? When you combine these two, what would be the formula?
BEF and then 2 on the bottom.
Exactly, BEF2. All right, very good. So what would be the name of this compound? Yes, sir. Beryllium fluoride, very good. And that's basically all you need to do for the rest of these. All right. Let's look at the second one, potassium and sulfur. All right, so do you have your tables? You need to be able to access your tables in order to do this. So what would be the formula for the potassium ion? Anybody? You can bring it up on your phone. What's the formula for the potassium ion? Oh, somebody answered in the chat. Oh, okay, somebody's asking where are the tables in Canvas. Let me show you quickly. Let me get out of this here. So you go to Files, and you click on Tables, and then it says here Tables Chemistry. You click on that as well, and download. Okay, mine is taking a while to download, but that's how you do it. Okay, so this is a table right here, and specifically, the ones that we'll be using for the questions I just talked about will be on, okay, so this is one of them. Let me just make this right side up. So this is one of the tables you're going to use. And then there's another table, this one here, right? And then there's a third table, this one right here, all right? So those are the tables that you're going to refer to in order to answer these questions, all right? And the reason why I provided those tables is because there are some ions missing in one that may be available in another and so on. So that's the reason why I provided all those tables. Okay, so let me get back to the, okay, where is it? I lost it. Oh, here it is, okay. So, okay, so potassium and sulfur. So what would be the formula for the potassium ion? Anybody? Or let me, well,
K plus.
K plus. And what would be the formula for the sulfide ion? I'm sorry? No, not quite. S2 minus. Okay, so we have K plus, we have S2 minus. So what do we do next? Yes, sir.
Well, first we K2S, but we have to write the whole formula.
I'm sorry?
We have to write the whole formula.
You can't, yeah, that's fine. I'm just showing you how we get to it. Right. So so how do we get the charges balanced or canceled out? We have the potassium with the +1 charge, and we have the sulfide with the -2 charge. How do we get the charges canceling out?
K2S.
Multiply the potassium by 2, all right? So when we put this together, what would be the final answer? K2S. And the name would be potassium sulfide, all right? Okay, very good. So what I'm going to do now is allow you to go ahead and do the rest, right? Basically, just follow the same rules as we just discussed. And of course, if you have any questions, please feel free to ask. That's why I'm here. And then we're going to move on to some other things. Okay, let's see here, somebody doesn't. Okay, so somebody says that they need help with the barium and nitrogen formula. Which one is that one? Let me see here. Okay, so who do want to help this person out with this one? What's the formula for the barium ion? Anybody?
Ba plus 2.
Ba plus 2 or 2 plus, doesn't matter how you do it. And what would be the formula for the nitride ion?
N minus 3.
Okay, so let me go back to this here. Okay, or N3 minus, same thing. All right, so here we have a situation where the barium has a +2 charge, the nitride has a -3 charge. So how do we get them to cancel out each other?
Ba3 and 2.
Okay, so in other words, you multiply the barium ion by 3 and the nitride ion by 2. So as he just said, the answer is Ba3 and 2. And what would be the name of the compound?
Barium nitride.
Barium nitride, very good. Okay, so I hope that helped whoever asked. Wait, who is it that asked that question? Miss Hersey, I hope that answers your question.
It did, thank you.
Mhm.
I have a question about the magnesium and sulfur.
Okay, magnesium and sulfur. Let's see. Okay, so what's the formula for the magnesium ion? Anybody?
It would be Mg2 plus.
Okay, and what's the formula for the sulfide ion?
The sulfide is 2 minus.
It's 2 minus, right? So basically, we don't need to multiply any of them by anything because this 2 plus will cancel out the 2 minus. So the formula will become MgS, and the name will become what?
Magnesium sulfide.
Exactly, magnesium sulfide.
So whenever you have like a positive and a negative charge that's the same number, they just cancel themselves out, therefore you wouldn't have a subscript.
Exactly.
Okay, thank you.
Mhm. Okay, are we almost finished with the first question? Or finished with it? Okay, so now in the case of part B, the level of difficulty will be stepped up a bit in some of these cases because what you'll find, and this was discussed also in the videos, let me go back to my writing thing here. There are some metallic elements that can form ions with different charges. So just to name a few examples, you have Fe2 plus and Fe3 plus, all right? Or you can have Cu plus and Cu2 plus, or you can have Pb2 plus and Pb4 plus. So these are all examples of different metallic ions, well, ions of the same element, but they can display different charges. So when these ions appear in certain compounds, you have to be able to distinguish between them, even though they have the same element, but you have to indicate also the charges. And there are a couple of systems that are used in IUPAC. The one that is most easy to understand is what is called the stock system. All right, and basically, according to the stock system, simply in terms of naming, okay, where is this? System, all right? Simply, we name these ions by writing down the name of the element, and then we indicate the charge in the form of Roman numerals within parentheses. So for example, Fe2 plus, the name of that ion is iron 2, whereas in Fe3 plus, the name of that ion is iron 3, all right? And then this one is called copper 1. This one is called the copper 2. This is called lead 2. And this is called lead 4. All right? So whenever you have a situation where a metal atom or ion, or metallic element, I should say, can form ions of different charges, that's how you indicate the charges, right? So that you can distinguish between those ions. And that can have consequences for the formulas of the compounds that these ions will form. So for example, and I think this is an example that we discussed in the videos. If you look at, for example, the compound formed between Fe2 plus and the chloride ion, right? If we go through the rules that we mentioned before, in order for the charges to cancel out, we're going to need 2 of these here. So therefore, the final answer becomes FeCl2. On the other hand, if instead of Fe2 plus, you have Fe3 plus, then in this case, you're going to need 3 chloride ions, in which case the formula becomes FeCl3, right? So the name of this compound is iron 2 chloride. And the name of this compound is iron 3 chloride, all right? So that's how you deal with these situations where you have the possibility of a metallic element forming more than one charge in their ions, right? You have to indicate in the name the charge using Roman numerals, right? And also you have to do the same thing as we did before in terms of determining the formulas for the compounds that they would form. One other thing I need to add too, and that is that for those ions or for those elements, metallic elements that display only ions with a particular charge, then you do not use any Roman numerals to indicate the charge, right? Because according to IUPAC, that is a bit redundant, all right? So this something like, for example, like sodium, right? You don't say sodium 1 chloride, it's simply sodium chloride because sodium cannot form any other ion excepting the one with the +1 charge. Another example would be, for example, magnesium, right? So you wouldn't say, for example, magnesium 2 oxide, for example. The name would simply be magnesium oxide, all right? Okay, so now that I've covered that, if there are no questions about this, then let me go to the second part of this assignment. So here you're asked to name these compounds. So let's deal with the first one. Let me get to my writing function here. What's the name of the first compound here?
Calcium chloride.
Calcium chloride, very good. Yeah, please forgive my chicken scratch here. Okay, what's the name of the next one? Iron 2 nitride. Now, do I need to explain this? Anybody have any questions about this one? Everybody understands why this is 2? Going once, going twice. All right, what about this one? What's the name of the third one?
Titanium 3 bromide.
Titanium 3 bromide, very good. What's the name of the fourth one? Copper what? Copper 1 phosphide. All right. What about the fifth one? Anybody? What's the name of the fifth one? 10, 4, whoops, 4 is IV, Roman numerals. And then what? Selenite. Okay, so I think you guys got the gist of it. So I'm going to leave you now to try the others. Again, if you have any questions at any of these problems, please feel free to let me know. All right. Oh, and by the way, for these questions, you're given the formulas and you're asked for the names. And then there's a second half where you're given the names and you're asked for the formulas. All right. So I think you guys should be able to handle that. Let me clear this here. Okay, so what I'm gonna do now, since we have 15 minutes left, I'm gonna ask you to hold off on completing part A for now, because I want to talk about another type of binary compounds and how we name those, and the rules are a bit different when it comes to naming these compounds. So we're talking about binary covalent compounds, which are different from binary ionic compounds. Let me get to my writing pad here. So in the case of binary molecular compounds or covalent compounds, basically, again, it's two elements, but they're both non-metals, all right? So I'm just to give you a couple of examples, I'm talking like, for example, carbon dioxide or sulfur tetrafluoride or phosphorus triiodide. Okay, so these are examples of binary molecular compounds or binary covalent compounds. They're binary, they each contain two elements, and they're molecular because they're made up of non-metallic elements, right? So we were dealing with ionic compounds earlier where one element is a metal and the other is a non-metal. In this case, one element, well, both elements are non-metals, right? So there are a couple of things that we need to be aware of when it comes to naming these compounds, right? The first of which is which one comes first in the formula or the name. And the simple answer to that is it depends on their relative positions in the periodic table. So basically, the one, if you have two elements in the same compound, two non-metallic elements in the same compound, the one that's further down in the periodic table and to the left would be the one that is indicated in both the formula and name first, right? So for example, in the case of the compound formed between carbon and oxygen, if you look at the periodic table, you see that carbon and oxygen are in the same period, but carbon is to the left of oxygen, right? So carbon is indicated first, and then the oxygen is indicated after, all right? The other thing too you need to be aware of is the use of, well, let me not go into that quite yet. The other thing you need to, let me see here. Oh, okay. So another thing you need to be aware of is that when you're naming these compounds, the first element in the name, you write down the full name. So in this case, it's carbon, all right? And then the second element, now, you have to indicate, in this particular case, the element itself, and it would be oxide. So it's kind of similar to what we talked about when it comes to binary ionic compound, in that you use the stem of the name of the element and then you end with IDE. Now, the third thing you need to be aware of is that unlike in the case of ionic compounds, we need to indicate the number of atoms of each element present in the molecule. That's one big difference between naming ionic compounds and naming molecular compounds. Because when we're naming ionic compounds, we do not care in terms of the number of atoms or ions present in the formula. We do not care in terms of naming. However, in the case of molecular compounds, we do need to indicate the number of atoms of each element present. Now, that's why the name of this compound is carbon dioxide, because you'll notice that there are two atoms of oxygen present in this molecule. And there are some prefixes that you guys simply need to know, all right? Mono for one, di for two, tri for three, tetra for four, and so on, right? So these are the prefixes that you're going to use to indicate the number of atoms of each element present in the molecule. Now, you might be wondering, okay, so why don't we use any prefixes for the carbon right here? And the answer is that there's a slight exception to the rules when it comes to the first element indicated in the formula for which there's only one atom, right? If there's only one atom of the element for the first element, then according to the IUPAC rules, no prefixes should be used. So therefore, you should not use mono, right? So therefore, it is incorrect for you to say mono carbon dioxide. That is incorrect. You simply say carbon dioxide, all right? In this case here, the name of this molecule is sulfur tetrafluoride, all right? And then in the case of this molecule, it's phosphorus triiodide, all right? Now, in this case here, N2O5, because you have 2 atoms for the first element here, you do need to indicate the number of atoms using the appropriate prefix. So the name of this compound would be dinitrogen pentoxide. And let me just say here that you can also call this dinitrogen pentaoxide. All right. IUPAC allows for the use of either pentoxide or pentaoxide. As far as IUPAC is concerned, both are correct. All right. So that's basically, oh, there's one more thing I need to say when it comes to naming binary molecular compounds. And this deals specifically in situation where one of the 2 elements in the molecule is hydrogen. So let me just write this down. If hydrogen is present in a binary molecular compound, then no prefixes are used. Okay, so let me explain. Let me use an example of this. So for example, let's say you're given H2S, right? Then you're not going to use any prefixes at all for any of the elements, right? So the name of this compound would simply be hydrogen sulfide. Or if you're given HBr, the name of this compound is hydrogen bromide, all right? So if it's a binary molecular compound where one of the 2 elements is hydrogen, then you do not use prefixes for either hydrogen or the other element it's combined with, right? So those are basically the rules that you're going to need to answer the question in part C, right? Especially on page 4 and 5. All right, so those are the rules that you're going to need for those questions. All right. Okay. So before you guys leave, let me remind you that your first test will be next week. All right. And I've decided to make sure that that test is based on the first 4 chapters. All right. That's the reason why I made sure that I've graded them and sent them back to you. And I think I have published the answer keys. Let me see. Let me make sure of that. I think I have published the answer keys to oh, I didn't publish 4, so let me do that now.
First 4 chapters are on the test,
Yes, sir.
and not this worksheet.
No, not this worksheet. In fact, this worksheet, I want you guys to complete it by next class. Okay, so it's there. All right, so assignment 4, answer keys there. So remember now, you're going to be doing a test in a testing center, and you can do it at any one of the testing centers here, Ocala, or Levy, depending on which one is most convenient for you guys. And I think you have to go online and make an appointment. The only thing you're going to need to take with you to the test is a pen and a calculator. I'll provide everything else for you. The test, the tables, scratch paper. Oh, and you need to bring your calculator as well, right? That's all you need to bring to the test, all right? So I'm going to, of course, make arrangements for the test to be available between Monday and Friday of next week, all right? So make sure that you make the appointment and make sure that you do the test by Friday, all right? And I think that's it. Any questions? No, it's actually, you know, I'm glad you asked a question. Let me give you, I'm going to post or publish an example of a past test. In fact, let me publish this right here. Past test keys. You might find this helpful. So let me just open this up to show you what you can look forward to, something similar to what you look forward to. So this is test 1 and 2 from some time ago, back in 2018. So here it is. Well, back then I used to tell students, I used to make them answer 2 questions, but now I just say all questions. And these are some topics that you may not have covered yet. So, oh, wait a minute. Oh, that's test number 2. That's the reason why. Okay. Let me see what test number 1 is all about. Okay, so this is test number 1. Some sig fig calculations. Some of what you learned just now, but this, you won't be given this on the test, so you don't have to worry about that. Some equations which something like this you could get. Right, so that just gives you a feel for what the test is like. Basically, my emphasis, which is what I think I said from the start of the semester, is that, you know, you guys should be able to solve problems based on what you'd have learned in class, all right? So, you know, I like to see the work, you know, shown, all the setups and so on. You know, I'll be looking for things like sig figs, units, all that good stuff, all right? Okay, any other questions? Any other questions? So if there are no other questions, that's it for today. So make sure you complete that particular assignment by next week. I'm going to, yeah, make sure you do that. I'll collect it next week.
Do we still have a Zoom meeting next week?
Yes, we still have class next week, yeah.
Thank you.
All right, take care, folks.
Have a good one.
Thank you.
Mhm.